At this time, I'd like to introduce our presenter, Lisa Weller, Product Manager for System Sensor. Lisa, take it away.
Thank you, David. As David mentioned, my name is Lisa Weller. I am a Product Manager in our Audible Visible Business Unit here at System Sensor. The subject for my presentation today includes changes made to the new 2010 edition of NFPA 72 in primarily regards to intelligibility. This is important because we know the inclusion of the new intelligibility requirements in the code will change how voice evacuation systems are designed. At System Sensor, we spend a lot of our time finding ways through the use of our products, training, and online tools to equip our customers and help them meet these new requirements. First, we'll take a look at what intelligibility is, including a quick look at the overview of how the concept of intelligibility has developed over time in the code and how it's currently defined. Then I'll talk about some of the main factors that affect intelligibility in a voice system. Next, we'll look at the code, the current code requirements for intelligibility. Here I'll provide an overview of some key sections of the code and define some new terms that have been added as well. I'll also talk a bit about applying the code, including intelligibility measurement methods for spaces that require intelligibility. And then finally, I'll provide a quick overview of our System Sensor SpectrAlert Advanced Speaker and Speaker Strobe line and describe how our speaker products can aid in system design and briefly talk about some software that is available to aid in the design for intelligibility. First, let's quickly go over some terms related to intelligibility that you'll hear throughout this presentation. First is ADS, or Acoustically Distinguishable Space. This is a term that has been added to NFPA 72-2010. And defining acoustically distinguishable spaces during the planning phase of a project will become important in designing for an intelligible system in accordance with the new requirements. You'll be hearing a lot about this concept later on in the presentation when we go over our code overview. STI stands for Speech Transmission Index, and CIS stands for Common Intelligibility Scale. Both of these are testing methods that are quantitative for measuring intelligibility that are both done with the use of a test meter. The STI, or STIPA, is the most common test method used and is a weighted average of the response to fluctuating modulation frequencies. And the CIS method was created to map all different methods for testing intelligibility to the same scale so that all the different results could be compared. And finally, ECS stands for Emergency Communication System, and MNS stands for Mass Notification System. I use these terms pretty interchangeably. The only difference I see is that MNS is a military term and ECS is the term that NFPA has chosen. And one other side note is that mass notification, as according to NFPA, can also just be a subset of an entire ECS system. Looking at a bit of history, 1999 was the first time the concept of intelligibility was introduced into the code as part of NFPA 72. The information was only included in the annex, and basically it said that emergency communication systems shall be intelligible, and specifically they should meet or exceed a CIS score of 0.7. As I just mentioned on a previous slide, the CIS is one of the ways to measure for intelligibility. Moving forward in 2002, NFPA 72 expanded the information included in the annex on intelligibility to just add some additional information. And then in 2007, we didn't see any additional changes to the code. Looking a little beyond the NFPA code, the final version of the United Facilities Criteria document for mass notification in all military facilities was approved by all branches of the military in April of 2008. And this document spells out the mass notification requirements for all military facilities, which includes intelligibility requirements. And the requirements called out by the military are slightly different from what is called out in NFPA. And finally, just recently, in 2010, the new edition of NFPA 72 with the concept of intelligibility being moved from the annex for the first time and being added into the body of the code. And this was adopted and just released at the end of 2009. So moving forward, we'll look at the definition of intelligibility. As you can see, NFPA originally defined intelligibility as audible voice information that is distinguishable and understandable. This definition was first added to the code in 2002 and continued through the 07 edition. Then in 2010, the code came up with a new definition for intelligibility and now defines it as the quality or condition of being intelligible. And with that, they define intelligibility as capable of being understood, comprehensible, or clear. So when talking about voice evacuation systems, these definitions are somewhat ambiguous. What is comprehensible and clear to one person may or may not be to another. So knowing how to properly determine and predict intelligibility for each installation is increasingly important. So as an easier way to look at intelligibility, I look at it as a measure of the effectiveness of speech, which is usually looked at as a % of the message that is understood correctly. When I think about intelligibility, what I want to know is that the occupants of a building can understand the message accurately and are able to take whatever action is necessary based on that message. So there are a lot of different factors that will play into whether or not a message is intelligible. So before we go further into the code, I'm going to take a look at some of those factors now. When talking about intelligibility, I have often heard people say that either the speakers that they are installing are the most intelligible or the speakers that we make are the most intelligible. And I always like to point out that neither of these statements should be used when talking about intelligibility, because intelligibility is not something that can be specified on a data sheet. There are a lot of different variables that will play into the intelligibility of a message that is being played, so it is not something that is purely up to the speaker itself. On this slide, the only two factors that have to do with the speaker itself are frequency response and harmonic distortion. Some of the other factors include the signal-to-noise level, which has to do with speaker spacing, the volume of the speaker, and the ambient noise in the space. There are echoes and reflections, which have to do with the environment of your installation and the building materials that were used during construction. And finally, the talker and listener abilities will also have an effect on the score that you get. First, we're going to look at the signal-to-noise ratio. This is a comparison of the sound level that is being produced by the speaker as compared with the ambient or background noise in the room. In order to help achieve the needed intelligibility, it's important to ensure that speaker sound output is 15 dB over the ambient. The actual requirement called out in NFPA states that the dB level needs to be on an average of 15 dB over ambient. So that should be the goal that you're shooting for. It is important to note that once you get much higher than that 15 dB over ambient, you start to see diminishing returns in regards to increasing your intelligibility in that particular space. So if greater intelligibility is needed, it's recommended that more speakers be used at lower tap setting as opposed to only increasing the sound output of your speakers. When installing speakers, each time the power output of the speaker is doubled or the number of installed speakers is doubled, the sound output will increase by approximately 3 dB. This is illustrated in the top two drawings on the right-hand side of the screen. And each time the distance between the listener and the sound source is doubled, there is a 6 dB loss in loudness. So when comparing the bottom two diagrams, you can see that when you double your distance from 10 to 20 feet, your dB level goes from 87 to 81 dB. Another factor that affects intelligibility is frequency response. For voice evacuation, speakers should ideally have a frequency range between 150 and 11,000 hertz because this is the frequency range of an average adult voice. UL requires a bit different frequency range. It's much narrower. It's from 400 to 4,000 hertz. As you can see from the third bullet, this UL range is much closer to the average human listening range. And when measuring frequency response, it's important for frequency to be as flat as possible in order to produce the most intelligible sound. The flatter the response over the frequency range, the better the speaker intelligibility will be. Another key factor in determining intelligibility is harmonic distortion. The average person can detect as little as only 2% distortion when listening to sound output. And once your sound output reaches 15% distortion, it's then considered to be non-intelligible. For purposes of UL testing, they allow for 13% distortion in the products that they test and approve. There are many additional factors that affect harmonic distortion. The list on this slide shows a number of them. All manufactured equipment has distortion built into it, so some examples of equipment that will affect the distortion of a message include the message generator, the amplifier, and the speakers themselves. So all of these different factors build on each other and then will have a cumulative effect on your intelligibility. Reverberation is another factor that will affect intelligibility. I think this one is the most important to understand because it really may be the one thing that has the greatest effect on intelligibility. So reverberation is often, as I mentioned, the main reason why it's very difficult and sometimes even impossible to achieve a required score in certain environments like large open areas like pictured on this slide that have very reflective surfaces in them. If echoes are spaced closely together, they are unable to be distinguished by the listener, so minimizing reverberation is key to achieving your needed intelligibility score. Some of the main factors that affect reverberation include room size, the reflective properties of the surfaces in the space. For example, an atrium with marble floors or walls will have a harder time meeting intelligibility than, say, a carpeted space. And the orientation of the speaker and the sound output of the speaker itself will also have an effect on reverberation. Now that we talked about some of the factors affecting intelligibility, some tips for achieving the required intelligibility score include, first, avoiding the installation of wall-mounted speakers in large rooms with ceilings up to 15 feet, because this will contribute to more reverberation because of the distance between the opposite walls that the speakers would be installed on. When the ceiling heights are greater than 20 feet, ceiling speakers should not be used because the distance between the listener and the sound source is greater. And also areas with both high ceilings and highly reflective wall surfaces, such as marble, will cause additional challenges with intelligibility. And finally, there should not be more than one door between a speaker and an occupant who will need to understand a particular message because, on average, a closed door will cause a loss of 25 dB. David, it looks like we're at our first poll question.
Yes, we are. So I'm going to go ahead and launch this poll question, and if those online could go ahead and answer it, we'll give you a few seconds. So have you done any projects where NFPA 72-2010 intelligibility code must be followed? You can just click on the response that's appropriate for you or your business. So think about projects that you've done maybe in the last 6 to 12 months. We would like to get about 80% of you to vote, and we're approaching that number. We have right at 160 people joining us for this webinar, so a nice turnout. Thank you for joining us. And I just do want to remind you, while we're waiting for the final folks to vote, if you do have any questions for our speaker, for Lisa Weller, go ahead and post it online using the question icon. All right, we've got almost 90%, so thank you for voting, and I'll go ahead and share those results with you. So, Lisa, it looks like about 24% of this audience, of course, a non-scientific poll, but 24% of this audience has had to use the intelligibility code, and 76% has not. So I'll bring those results down, and we'll get back to you, Lisa.
Okay, sounds great. Thanks, David. So now we'll look at some of the changes to the code. First, a new term has been added to NFPA 72 that is important to NFPA 72 that is important to understand. That is the acoustically distinguishable space, which I mentioned at the beginning of this presentation. An acoustically distinguishable space, according to NFPA, is an emergency communication system notification zone or subdivision thereof that might be an enclosed or otherwise physically defined space, or that might be distinguished from other spaces due to acoustical or environmental or use characteristics such as reverberation time and ambient noise. An easier way to explain this would be to take a look at the room that you're sitting in now. For example, I'm sitting in a conference room and this room could be considered its own acoustically distinguishable space. And once I leave this room and go out into the hallway, I would then be considered to be in another acoustically distinguishable space. In this example, some of the reasons why these two locations would be looked at differently include the fact that the area I am in now has carpeted floors, whereas the hallway has tile floors. This would cause these two different locations to have different acoustical properties. So some other environmental differences that could also be present would include different ceiling heights and different ambient noise conditions. Now that you know the definition of an acoustically distinguishable space, we will next look at how the code requires them to be determined. First, each acoustically distinguishable space is determined by the system designer during the planning and design phase of an emergency communication project. Second, each acoustically distinguishable space shall be identified as either requiring or not requiring voice intelligibility. And then finally, when intelligibility is required by the AHJ, the acoustically distinguishable space assignments will have to be submitted for review and approval. As I mentioned, each acoustically distinguishable space is decided upon at the beginning of the project and is decided upon based on different physical barriers, the material changes, and the different ambient sound levels. The reasoning behind making the determination as to which areas are required to meet intelligibility scores and those areas that are not up front is to help avoid over-designing the entire system and to avoid spending time testing in areas that can be deemed impossible based on the characteristics of the space. So one of the goals of the wording included in the new version of NFPA 72 is to help avoid over-design with these new intelligibility requirements. Intelligibility requirements are not only in Chapter 18, they have also been added to a totally new chapter in NFPA 72. This chapter is Chapter 24 on Emergency Communication Systems. This new chapter is where the guidelines for ECS or MNS are laid out. For those of you who are not aware, we did have an entire webinar on emergency communication systems and the new code information a couple of weeks ago. If anyone is interested in learning more about this or listening to that webinar, it is archived on our website at systemsensor.com. In regard to intelligibility, Chapter 24 just calls out that the system should be capable of reproducing intelligible messages in accordance with Chapter 18, which we already covered. Some additional information regarding voice evacuation for emergency communication systems in Chapter 24 is about designing and laying out the system. The points on this slide just ensure that the intelligibility and audibility are taken into consideration at the beginning of the project so that the system has been laid out in a way to provide the most optimal results for intelligibility and audibility. Currently, there are some software programs that are commercially available that can help in the design and layout of a voice evac system to design for intelligibility. And I'll briefly touch on this software at the end of this webinar. As I mentioned earlier, the Department of Defense has its own document that spells out requirements for mass notification, which includes speaker intelligibility. The requirements for some branches of the military are a bit stricter than those called out in NFPA 72, specifically for the Army and the Air Force. Again, I'll go over intelligibility scoring systems a little bit later, but these branches require an STI score of 0.7, which is at the higher end of the good range for intelligibility scales. I'll show you a chart that lays that out in just a couple slides. The Navy and Marines require a minimum SPI score of 0.5, which is the same that is being called out for NFPA 72. All mass notification projects in the military are required to verify the intelligibility scores using either STI or CIS. All measurements should be taken at head level for each space depending on what that space is used for, whether it be a sleeping space or an office space or what have you. Finally, for mass notification in military applications, it's required that an intelligibility meter be used to take 3 measurements and then use the mean of those 3 readings to compute your intelligibility score at each location. So it's important to point out that the military requires the use of a meter even though there are some other testing methods available. David, it looks like we're at our second poll question.
Yes, we are, and I do have a couple questions posted from attendees, so I would encourage you to continue to ask those online, and we'll handle those after each poll question. The second poll question is, aside from military installations, have you been required to conduct intelligibility testing on any projects? So if you could just go ahead and click yes or no, and we'll leave the poll open for a few more seconds to see what we might have responses. And we're up to 163 folks joining us today, so we do appreciate you attending today's webinar. Okay, we're right at 90%, so I'm going to go ahead and close the polls. Thank you for voting, and I'll share those results back with you. Lisa, it looks like aside from military installations, about 82% are saying no, that they're not currently conducting intelligibility testing on any project. We do have a couple questions here. Let me go ahead. I think I can answer the first one. A number of respondents have asked if we are going to be posting an archive of this webinar online or if they can get the slides. And we will, yes, in fact, that'll be something we'll cover right at the end, but we will be posting an archive of the webinar online at systemsensor.com/webinars, and it should be available, if not by the end of the week, by early next week. Lisa, there was one question that came in about how it was on one of your earlier slides when you were talking about frequency response, and is there a way that they can adjust, is there field settings on speakers to adjust for frequency response?
No, there's not. Frequency response is not something that can be changed in the field. It's something that is tested for in a lab setting only.
Okay, all right. And I think you'll cover this later, but one of the attendees asked, you mentioned intelligibility meters. They're asking for a recommendation on a good intelligibility meter. You want to wait to cover that later in the presentation?
Yeah, I can cover that later once we talk about the meters themselves.
Okay, all right.
If I don't answer the question, if I miss it, please just let me know and I'll make sure I address it.
Okay. And then the last question was, or last question for this session was, if you're not getting a good intelligibility score, how can you tell which factors might be affecting intelligibility? And they mention here carpeting, ceiling, furniture, etc.
It really could be any number of those. I mentioned that there is some software available. I haven't talked about it yet, but that software available allows you to input all of those variables at the beginning of your project so you can take into account different structures in a building and different materials on the wall and the floor, and that will let you know where you should install your speakers and what they should be tapped at in order to meet a specific intelligibility score. If you're not using any particular design software, it's kind of very hard to tell exactly what is having the effect on intelligibility. Our recommendation, as I mentioned earlier, is more speakers at lower tap settings are what is going to help you meet the scores that you're looking to meet.
Okay. All right. Well enough. That's all the question we have posted at this time. Why don't I take the poll down and we'll get back to your presentation.
Okay. Thank you, David. So in a nutshell, this chart will illustrate what the code changes are saying. The process starts with determining the different acoustically distinguishable spaces. Then you'll determine whether or not intelligibility will be required. If it's not, your process is complete. If intelligibility is required, you'll move on to the next step, deciding if measurement is or is not required. If measurement is not required, the process is again complete. But if measurement is required, then you'll have a final step in deciding what type of measurement will be performed. It could be either subject-based measurement or objective-based measurements. And as I already mentioned, in the military, they only allow for the objective-based measurements. And the subjective versions are not done quite as often, but they are available for those of you who don't have access to an intelligibility meter. In the new Chapter 18 for notification appliances, the code calls out that within the acoustically distinguishable space where intelligibility is required, voice communication systems shall reproduce pre-recorded, synthesized, or live messages with voice intelligibility. In each of these defined spaces, measuring for intelligibility may or may not be required. Remember, understanding the concept of acoustically distinguishable spaces will become important during the design process, as these spaces must be designated at that point in the process. In some instances, intelligibility may be required, but not have to be tested or verified. Some areas would include hotel rooms or some smaller office spaces. In spaces such as these, it's enough just to ensure that those conducting the testing can hear and understand the message in these small spaces. It's considered adequate for these spaces to only meet the audibility requirements, and it's assumed due to the size of these spaces that occupants will be able to understand the messages. When intelligibility is required and must be measured, more commonly quantitative methods are used for conducting intelligibility testing. This testing requires the use of an intelligibility meter, which is the most accurate and most feasible way of conducting intelligibility testing. These meters measure either the STI or the CIS test scores. Typically, they'll have the capability of measuring both depending on what setting is chosen. If you don't have a meter, there are a number of subjective test methods that are conducted using a group of people who will listen to a passage that is either spoken or played over the speaker system. Then the group of listeners will be asked to recall how much of that passage they were able to understand. This would then determine the intelligibility score. The two main types of tests done in this manner are the modified rhyme test and the phonetically balanced word score. Both of these testing methods have different lists of words, whether they are just random words read through the speaker, or for the modified rhyme test, they would be a set of words that sound similar and being asked to recall which ones you were able to understand properly. But as we pretty much recommend, is that using a test meter is the way to go. We recommend it just because it is a lot more feasible to use a meter. They are very expensive. I've looked at the majority of those that are available on the market and found that you're really not going to be able to get one for anything under $3,000 to $3,500. I did say that I would talk about the different meters that we've evaluated. All three of them are shown on the slide right now. The one on the left is a Quest Technologies meter. The one kind of in the front is called Ivy. It's a meter manufactured by Samsung. And then the one in the back inside of the case is the Goldline meter, which I think most people are probably familiar with. We don't specifically recommend one particular meter over another. As System Sensor, our engineering team has evaluated these three different meters, and the one that we have chosen is the Quest Technologies meter, which is the one up on the screen on the left. And we chose that one just for its ease of use, and it's a lot more portable. It's a handheld meter, and we feel that it's been performing well for us so far. So that's the choice System Sensor has made based off of what we were able to gain from evaluating the other meters. So in case you are interested in purchasing a meter, any of these can be found by doing just a quick Google search on the internet. And finally, if you're interested in getting more detailed information on intelligibility and intelligibility testing, I would recommend taking a look at Annex D in NFPA 72, the new 2010 edition. This is an entire index that is devoted to intelligibility. And next, I'll talk about the basic steps that are involved in running an intelligibility test. the process is pretty straightforward. At the beginning of each testing period, which I would say is at the beginning of each day the meter is used, it should be calibrated using the instructions supplied by the meter manufacturer. After the calibration is complete, you'll check to ensure that your meter is in the proper test mode or setting, because most intelligibility meters also have the ability to do other types of acoustical testing. So it's important to ensure that it is in the right test mode. Also, make sure that the proper setting for the scale you're using is selected. Next, you'll measure the ambient dB in the space. Then you'll be ready to run your intelligibility test tone and ensure that your dB reading with the test tone is at least 15 dB over your ambient. And at this point, you are now ready to run your intelligibility test. Now you can make note of the score and move on to your next test area. One thing to point out, most meters will have the ability to save your test data internally and then be downloaded to a computer at a later time. When conducting intelligibility testing, especially in an emergency communication system, 90% of all measurements taken in each ADS must meet the required intelligibility scores in order to be considered acceptable. As you can see from this slide, each acoustically distinguishable space must have a measured STI or CIS score to be considered acceptable. Most meters will have the ability to test for either scale, but if not, as you can see on this slide, there is a chart that's available to convert between STI and CIS. When looking at the required scores that must be achieved, it's important to note that these requirements fall on the lower end of the intelligibility scale. As you can see, an STI score of 0.45 falls in actually the poor range, and so obviously they're not asking you to have the best intelligibility that there is available. So this is on the low range, and this is your minimum score that you must meet. And then on average, you're supposed to meet an STI score of 0.5, and this is also falling into just the fair range. So the score requirement levels were not set at an unreasonable level and should not require any excessive over-design of the system in order to meet these intelligibility scores. David, I think we're at our final poll question.
Okay, we sure are, and we do have a number of good questions posted from attendees as well. The last poll question I'll launch here is more product specific, and we're just inquiring to see if you've had a specific product need in any mass notification or intelligibility type installations. So have you been required to specify or install a dual strobe speaker strobe? So three possible responses. There could be two yes answers, yes in general, or yes but in military applications only. We're trying to figure out or to try to determine if it's one or the other, and then obviously no is the third response. So we'd appreciate you taking a minute and going ahead and vote in our poll. That'll help us determine some product needs in the future as well. Good, we're about 80%. I'm going to go ahead and close the poll. And just because we do have a good audience with us, good size audience with us today, I'm going to share these results with you as well. So at least it looks like about 21%, it's tied in fact, yes in non-military, but yes in military applications as well, and 21%. So 42% of our audience has been involved in this. And then we have 59, boy, that didn't quite turn out right. I'm not sure why those numbers don't equal 100%. So we'll have to look at the numbers that back that up. I'm going to go take that down. We do have a couple of good questions here. Let's see the first one. Let me get to it. I'm sorry. Scroll to the right one. It's does the stock microphone that comes with a standard fire alarm panel, is that adequate for an intelligibility reading or needs, or do you need to replace it with a higher grade microphone?
Well, I know with the panel, I know I've seen intelligibility testing done, and they do use that microphone for intelligibility testing. So I would imagine that would be adequate. You want to, when you're running your intelligibility testing, you want to be using, the equipment that's going to be used in the case of an emergency. So yes, I would say use what you're planning on using, throughout the installation of that system.
Mm-hmm. Mm-hmm. Okay. Next question deals with intelligibility as well. Are there specific installations where intelligibility would not be required?
That is really going to be dependent on the AHJ to make that decision. When we look at areas that may not require intelligibility, we look at large open areas where they have a lot of windows or a lot of reflective surfaces, such as open atriums and entrances to buildings where it may be virtually impossible to achieve an intelligibility score. And then a lot of times we see areas such as I mentioned earlier, the hotel rooms and office spaces, that it just doesn't make sense to do testing in all of those areas, because if there's a speaker present, you should be able to understand what, the message that is coming across.
Okay. All right. This attendee is asking for maybe clarification. His AHJ talks about audibility versus intelligibility, and he wonders if we want to describe what the difference is, or if he needs to educate the AHJ on the difference.
Well, audibility is just the dB output of your speaker, or the dB that you're getting in your environment. So for intelligibility, it is recommended to get the score that you need to be 15 dB over your ambient noise level. And intelligibility is a totally additional thing to audibility. Audibility is a part of intelligibility, but intelligibility is the sound output, but it's also how well the message can be understood.
Okay.
So they are definitely two totally different things.
Okay. All right. This attendee's commenting here that his AHJ simply stops and listens to determine intelligibility, and he wonders, since the AHJ is saying that's a determination, is that suffice, or will he have to buy a meter in the future?
At this time, that would suffice. There aren't any prescriptive requirements for exactly how you need to measure your intelligibility. In most of the codes that people are using right now, I mean the 2010 edition, which is the first code that has intelligibility information in the body of the code, most likely hasn't been accepted anywhere yet. I know a lot of places are still on the 2002 version of the code, so if that's the way your AHJ wants to do it, that's really up to him. I would imagine that, down the road in a number of years, actually being required to test for intelligibility will become much more prevalent. And then, of course, if you're doing installations in a military environment, you will have to do testing with a meter.
Okay, very good. So when the code changes in a specific municipality, that may prompt a change to use meters versus the stop and listen approach. Okay, the question, a follow-up on measurement of the dB with the test tone. The attendee wants us to confirm that that's done in the field, and is there a specific dB that it should be tested at using a microphone?
No. Whatever your ambient noise is in the space that you are measuring intelligibility, your dB level with the test tone should be 15 dB above your ambient, and that's where you would run your intelligibility test. So I hope that answers the question.
Okay, all right. And kind of a follow-up to that, when you measure dB over ambient, during what part of the message would you be taking your reading? And maybe he's thinking of an audible message, like a voice message versus a tone.
Right. When you're running your intelligibility testing, you are never doing your intelligibility testing with the voice message itself. You're always using the test tone, which will be on a CD that is supplied with the meter when you purchase it. So when you're running your testing, in order to get an accurate score, you need to be using that test tone. Okay.
All right. This attendee is asking for, looks like maybe some product plans or product awareness. Are there speakers available that automatically adjust output for ambient sound?
None that I am aware of at this point. I know we do not manufacture speakers that do that, and we don't know of any that do that either.
Okay.
Any other speakers that do that.
Okay. All right. This one I think you've answered here, but I'm gonna ask it because it seems to be a common question. How can you ensure to the HJ that anyone that may use a manual mic for announcements will meet these requirements when everyone has different voice characteristics? Isn't that the tone test versus voice?
That's right. You won't be using a voice test when you're running your intelligibility, testing with your meter. They're always using a test tone, but that is true. Speaker ability and listener ability will have an effect on whether or not somebody is able to understand a message, but in terms of running intelligibility testing, you're always going to be using that test tone along with your meter.
Okay. This is more of a question maybe back to our audience, but Lisa, if you know it, go ahead and tell it, but if not, let the attendees chime in as well. He's wondering if there's any rental vendors that will rent intelligibility meters, whether it's a local rental shop or some place like a Radio Shack. Are we aware of that, or should we ask the attendees to respond to that?
What I can say in regard to that, the people that I know who, it's either the people who are using the meters themselves will purchase one. I know that we own a couple meters, and we provide them to our salespeople to help out with intelligibility on a, sort of an as-needed basis. I think other manufacturers do that on occasion as well, but in terms of being able to rent a meter, I have never heard of anyone, doing that.
Okay. So
they are very expensive and require calibration frequently, and having them sent out like that would be, you wouldn't be guaranteed that you're going to get, an accurate reading.
Right. So let's kick that back to the attendees. If you do know of businesses that do rent intelligibility meters, we'll share that with the rest of the group. Lisa, last question for this session here. This attendee says that most testing that he's done is prior to occupancy, and in most cases there's no people, no furniture, maybe even no wall coverings. And how does an AHJ account for this variance?
You know what? That is a lot of times when the testing is completed. Once you add, wall coverings and carpeting and, different, cubicles or whatever might be in the space, your intelligibility score probably will be different. The only way to account for it is to run another test. And, there's really nothing else you can do but run another test. If your AHJ is satisfied with running the test before the space is filled, then that's really up to him to decide. That's
his jurisdiction to determine. Okay. All right, that's all the questions we have at this time. Why don't we go back to your presentation?
Okay, thanks. Now that we are coming to a close to this webinar, I would like to briefly just mention some of the system sensor products that round out our speaker offering. We offer speakers and speaker strobes that are available in wall and ceiling versions for both indoor and outdoor applications, and are available in both red and white. We also offer two different versions of our speakers as well. Our standard speakers are what we call our high fidelity speakers, and these will aid in intelligibility. And then we also offer what we call our high volume speakers, which will provide approximately an additional 3 dB output at each tap setting. Finally, as I noted earlier, we would like to briefly mention some software that is commercially available that can help aid in the design of an intelligible voice system. EASE 4.3 software is available for use by sound designers to model acoustical properties for specific environments and speaker configurations. So to help predict the intelligibility of a voice system using the system sensor SpectrAlert advanced speakers, we had testing completed by an outside lab on all of our speakers for use with this software, and these data files are now available on our website. And now that SpectrAlert advanced speaker data is available, voice evacuation system designers can use the EASE software to predict the intelligibility of their voice system prior to installation. Our speaker data can be downloaded at systemsensor.com/ease. You'll use checkboxes to select the speakers that you're interested in, and then you'll just click Submit for download, and all of your needed data will be provided in a zip file. To obtain an intelligibility prediction using this software, you'll import the speaker information into the software along with other variables such as room materials, ceiling heights, and speaker positioning. And then this will give you a predicted intelligibility score or let you know how many speakers you need to install where and at what tap settings. So again, if you want more information, you can go to our website at systemsensor.com/AV. And note that System Sensor, we only provide data to be used with the EASE software. We do not provide the actual software itself. So in summary, intelligibility is a new concept that has been added to both NFPA 72 and the UFC document for the military. It is important to take the time needed to learn about intelligibility and understand the different testing methods. If you are involved in voice evacuation or plan to become involved, it would be a good idea to look into purchasing an intelligibility meter as it is required by the military and suggested by NFPA. Conducting intelligibility testing is pretty straightforward but can be time-consuming, which is another reason the use of an intelligibility meter can be helpful. So since there are many factors that can affect intelligibility, it's important for these items to be taken into consideration during the design phase of a project. This brings us to the conclusion of our presentation. I'd be happy to take any additional questions if there are any.
We sure do. We have several more. The question is, does DOT attempt to standardize variable tones from live voice by specifying a female voice? Do we know an answer to that? Is there a female requirement or male requirement in voice?
In terms of DOT, is that, I'm assuming that they're...
DOD, I believe, is what.
Okay, Department of Defense. Okay.
Yes. Mm-hmm.
You know, I don't know if there are any specific requirements called out in the DOD that call for male versus female voices. I do know in NFPA they recommend, I might have this backwards, but I believe they recommend outdoor, they'll recommend that a male voice be used because it will project better. And indoor they look for a female voice because the frequency levels of our voice or female voices are more different from what the background or ambient noise would be. So I know that's what's called out in NFPA, but I don't believe there's anything called out in the DOD document.
Okay, all right. I think we had this question on yesterday's webinar as well, but can speakers that are labeled fire be used for messaging that is non-fire related?
The answer to that question is no. When you are doing an emergency communication or mass notification system, even if it is combined with a fire system, your speakers either need to be plain or marked with the word alert so that you know that whatever's coming out of that device is not just strictly related to fire. So it is called out in the military document and in NFPA that your speakers should either be plain or marked with alert.
Okay, all right. This goes back to your required but not measured spaces. Is there a defined list of required but not measured spaces? And if not, who defines this?
There is not a specific list out there that would call out exactly which spaces would and would not require intelligibility testing. That would really primarily be up to the age, Jay.
Okay. Okay. You mentioned reflective spaces, and if this attendee is asking a question, how can they work with their local architects to influence building design to have more favorable acoustic qualities?
I think that's just working together and trying to look at, what your goals of an installation are. I would imagine an architect's goals are going to be very different from somebody in the fire industry's goals who are just wanting to make sure that people are able to understand messages and be able to take appropriate action, whereas an architect is probably trying to make their building look in a certain way. So,
sure.
I mean, the best you can do is just work with that person to influence the decisions that they make in terms of design materials.
Okay, all right. This attendee is following up on one of your comments about speakers in tall ceiling environments. And they're specifically asking for ceilings greater than 20 feet, where should the speakers be placed?
For ceilings 20 feet or greater, for intelligibility, they are recommending that those speakers be located on the wall.
Okay, okay. and that the code height's determined by the code or by the AHJ, right?
Well, the height on the wall is determined by NFPA. It says that the speakers need to be at a minimum of 90 inches above the ground and have to be at least 6 inches below the ceiling.
Okay, all right. Here was a question as well about multilingual applications. Does the code address multilingual applications as it applies to intelligibility?
No, they don't. There is nothing called out in the code in regard to language. If you're using one of the subjective-based testing methods, there are lists of words that are used for that testing that are in English and other languages as well. And in regard to using an objective-based measurement method where you're using an intelligibility meter, you're going to be testing for intelligibility with a test tone, so the language of that message won't make a difference.
Okay, all right. This attendee is asking, how much is the EASE software, and can you remind them where to get it?
Yes, the EASE software costs $800, and if you are interested in purchasing it, you can go to www.afmg.eu. This is the company that makes the software. On that website, you'll see an area that says Partners List, and then you'll be able to find distributors that sell the EASE software.
Okay, all right. This is again on the EASE software. Is the EASE the best way to calculate intelligibility before construction begins, or is it more trial and error in the design with follow-up with an intelligibility meter after construction?
Well, using design software is definitely helpful and will give you a good starting point. I don't want to say that EASE is the best way. There very well may be other software programs out there that could be used. You know, I'm not aware of all the different software options that are out there, but EASE is one way to do it. Depending on your installation, if you don't have a difficult installation, trial and error may be your best route because the software is expensive. It takes a lot of learning to understand how to use it properly. So, you know, the software application is probably for areas where you might have more difficulty than others. But, I mean, using the trial and error method, if you're not getting the scores that you need, you would most likely end up having to go back and use additional speakers.
Okay, all right. This question deals with your ADS comments. Are there any intelligibility requirements for outdoor ADS environments?
No, they're not. When you're outside, there are no considered acoustically distinguishable spaces, and you also can't, you know, run intelligibility testing outdoors because, you know, obviously the sound is moving in a much wider area, so being able to test for intelligibility in outdoor applications would not be possible.
Okay. Another ADS question, can two rooms separated by a door be part of the same ADS?
No, they can't, unless there was some way to, you know, if it was in a room that could be separated by movable walls, but like in a general sense, no, because once you have a door separating one space from another, you'll, as I mentioned in the presentation, lose approximately 25 dB through that closed door, so those spaces will be able to be looked at the same.
Okay, all right. Here's a question I don't think we've seen before, but this attendee is talking about installing white noise systems in buildings, and he's wondering what effect they may have on intelligibility.
You know what? I have not yet heard that question. I can definitely look into it and try and get back to him with an answer, but that I don't know a definite answer to at this time.
Okay, all right, very good. It looks like I think we're at the last question, and then we'll go into the summary here. It was a question about reflective surfaces again. I think it's a follow-up to that one. Are less speakers with a higher setting better, or more speakers with a lower setting better in buildings that have a lot of reflective surfaces?
Pretty much in any application where you're looking to meet a specific intelligibility score, more speakers at lower tap settings are always going to get you a better score as opposed to fewer with higher tap settings.
Okay, all right. On behalf of System Sensor, I want to thank you for joining us today. As a follow-up, we will be sending you a brief survey in about an hour and would appreciate your help in filling that out. We do plan to reward one of you that complete the survey with a $50 target card. And if you have an interest in installation and application tips for duct smoke detectors, be sure to join us for a webinar covering that topic next month. Registration details will be available online under the training link at systemsensor.com early next week. Thank you again for joining us today. This does conclude our webinar. Please have a nice rest of the day.